Your objective for today. Today I will demonstrate my mathematical ability to identify two quantities that are proportional to each other when they have something in common. And we're going to start looking at what we know as proportional relationships. So let's go ahead and look at the first example problem. The problem says, I have a new soft serve frozen yogurt store opened this summer that sells yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed their dish, and this is what they had found. Okay, so here's the weight, and then here's what it costs for that. Now I want to know, are these proportional to each other? Meaning, do these equal each other? Now, I'm looking at the cost per ounce. Let's look at that. I'm looking at the cost per ounce. When I do that, because I'm not going to look at the weight or the ounces per cost, because that doesn't really tell me anything. I want to know, because the question was, did each person pay the same thing? Okay, and that's what we need to find out. So, and then we add another one. Okay. Alright, so we want to know, is this proportional to each other? Well, if we look, I did something to 12.5 to get me to 5. I did something to 4, or 10 to get me to 4, and I did something to 5 to get me to 2, and something to 8 to get me to $3.20. Now what I do, well, let's look. I'm looking at cost per ounce. So when I do that, I have the fraction 2/5, which I also know is equivalent to 4/10, which I also know equals 40 cents. So at least for these two, I multiplied 10 times 40 cents, 5 times 40 cents. Okay, so then if I look at 12.5, well, if I come over here and I multiply 12.5 times 40 cents, 5 times 5 is 20, I carry my 2. 4 times 2 is 8, plus 2 is 10, carry my 1. 4 times 1 is 4, plus 1 is 5. I have 2 decimals in my problem. I need 2 decimals in my answer. So I'm at $5. So that is 40 cents. And if I do the same thing to 8, I'm going to get the exact same thing as $3.40. So since I'm doing the exact same thing to every single thing here, every single weight I'm multiplying, I can say the cost is proportional to the weight. Alright? So, if I made this an XY chart, where this is X and this is Y, it doesn't matter what my weight is if I do the same thing. So if I have 40 cents times X equals Y. That's what this frozen yogurt company uses when they sell their frozen yogurt. They take the weight in ounces, they multiply it by this number here, and we'll talk about what that is in a couple of days, tomorrow, and then that equals my cost. Okay, so I can, whatever I put in here, I get out here. Alright, let's go ahead and look at your next problem. Okay, during Jose's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. So here again I have the time. So this is the amount of time. So at 1 minute I'm going to burn 11 calories. At 4 minutes I'm going to burn 44 calories. I want to know, is the number of calories burned proportional to the time? Okay? So I'm comparing this to this. Now, I would start out to find out, do they have something in common? Well, I'm going 11 to 1. 11 to 1 is 11. Okay, 22 to 2, if I divide that, that's 11. 33 divided by 3 is 11. 44 divided by 4 is also 11. So, is the number of calories proportional to the amount of time? I would say yes, it is, because you will burn 11 calories per every minute. At the stations. Because I always want to answer my questions in complete sentences. Okay, so here's another question. It says, if Jose jumped rope for 6.5 minutes, how many calories would he be expected to burn? Well, if I take this same example, I know that he's going to burn 11 calories per minute. So I'm going to take 6.5. I'm going to multiply it by 11. 5 times 1 is 5. 6 times 1 is 6. Move it over. 6, and 5 and 6. I add 5, 11, 7. Okay. Bring my decimal point because I have a decimal up there. Jose would be expected to burn 71.5 calories after jumping rope for 6.5 minutes. Okay? Now, what do I want you to take away from this? I want you to take away that if something is proportional, okay, if they have something in common. Right, and we've talked about a couple different things. You know, if we go back to our previous example, so if I want to write the equation, if I want to know exactly how this is going to work, okay, this is going to be my calories, correct? So this would be my x, and this would be my y, because I'm looking at calories to time. So I would have 11x equals y. 11 minutes times whatever x is, times how many, no, this needs to go the other way, my fault. Okay? So this is x, and this is y. So how many ever minutes, I'm going to multiply by 11, and that's going to be my calories burned for this activity that we're doing in PE class. Alright, we're going to talk more about what this is called later, but I just want you to understand that if we have something in common, then it's proportional. If we have nothing in common, it is not proportional.